Welcome to the session in which we are going to see one mean test. Now we'll consider this example to see the process of testing of hypothesis. Now if we go through the problem mentioned here, now the company claims that the average life of the product is this, at least 28,000 miles. That means this is the hypothesis which we are going to validate. That means here what the company claims is the average life of the product is at least 28,000 miles. Right? So this is the claim. We identified that this is the claim which we are going to validate. So to validate this, what is done here? So now, we took a sample. That is, we went for sampling. We took a sample. So where the sample consisting of, that is, to check this claim, they have taken the sample whose size equal to 40. That is, a sample of size 40 is taken, and here, because this is the hypothesis related to mean, now they calculated the mean of the sample. That is, here the mean lifetime of the sample is given, that is this 27,463 miles, right? And also the standard deviation correspond, that is 1,348 miles. Okay. So this is the scenario. Then what is that we are going to do is, based on this sample outcome or based on the sample statistics, what is the comment that we are going to make with respect to the claim given, that is mu greater than or equal to 28,000. And here one more thing is given, that is the probability of type 1 error is at most, that is the probability of type 1 error, that is the nothing but level of significance. That is, if we remember or recall, that is alpha is at most 0.01. Okay. This is. Okay. So this is what we are going to do here. So now if you see here, if you recall, like what we have done is, so here first what we have done is, this is the identification of the claim, that is null hypothesis we identified. Right? Null hypothesis is the one which we are going to validate. Now, as discussed in the earlier sessions, whenever we had null hypothesis, immediately we have to form or we have to choose the corresponding alternative hypothesis. So in this case, mu greater than or equal to 28,000 fails, then what is the alternate here? Mu less than 28,000. Okay. So this is the alternative hypothesis. Okay. So next we have to choose the corresponding test statistics. We have to see what is the size of the sample. Here n equal to 40 is the size. That means what we say is, this is the large sample. If it is the large sample, then we have to use the test statistic, that is z equal to x bar minus mu by sigma by root n. So we had H0, we had H1, and we have chosen the test statistic, that is z equal to x bar minus mu by sigma by root n. So next what we have to do is, we'll do the calculations and see whether the claim is valid or not. Now we'll write like this is the null hypothesis as discussed, mu greater than or equal to 28,000, and alternative hypothesis mu less than 28,000. Now here, based on alternative hypothesis, what we can say is, because mu is less than 28,000, we say this is one tail test. One tail test. Then particularly we can say it is mu less than 28,000, so we can say it is left tail test also. So next the LYS, as we discussed. Now because the size of the sample n equal to 40, which we say that it is the large sample, then we have to use the z distribution or z statistic, that is z equal to x bar minus mu by sigma by root n. Now plug in all the values, that is x bar equal to the mean of the sample given 27,463, then the mu, that is the mean of the population, then sigma, that is the standard deviation of the population, and n is the size of the sample. So then we calculated, then the calculated value what we are getting is minus 2.52. Next, now what we have to do is, for the given scenario, we have to see what is the critical region. So here what we have to do is, so first we have to see whether it is a one tail test or two tail test, and next we have to see what is the size of the sample, that means what is the distribution we are going to use. Then next is what is the level of significance. Now here, so because the sample is large sample, we are using Z distribution. So we are using Z distribution. And the level of significance, that is the probability of having type 1 error, is 0.01, that is alpha equal to, this is the 0.01. Because it is one tail test, therefore, and particularly it is left tail test, the complete the alpha equal to 0.0 is in the left side. Next, we have to see the normal distribution tables, and from normal distribution tables, for the given probability 0.01, what is the corresponding Z value. So here it is different from what we did earlier, where Z values are given here, where probabilities are given here. Now in this case, we know the probabilities, then we have to find the corresponding Z values. So from normal distribution table, for this level of significance alpha equal to 0.01, so what we are getting is minus 2.33. So from this, what we say is, now this region, what we call as region of rejection, and this region, critical region, that is region of acceptance, right. So this is theoretically what we had. Now we see the given problem where the Z what we calculated is minus 2.52. Then we have to see whether this calculated value lies in the region of acceptance or in the region of rejection. So if you see here, this minus 2.52 will find here, that is in the region of rejection. Therefore, what we say is H naught is rejected, that is null hypothesis is rejected. That means alternative hypothesis accepted. So this is how we have to do a problem related to testing of hypothesis, where the hypothesis is related to mean of the population. And we can continue the discussion here itself, where suppose the H1 is mu greater than, suppose for this problem, suppose it is like this, where mu is greater than, then also we say this is one tail test, but in this case it is right tail test. If it is right tail test, then the critical region is if you see here, then it becomes like here we will see this alpha equal to 0.01, right. So this is the region of acceptance and this is the region of rejection. Now in the similar fashion, we have to see what is the corresponding value. And third scenario, suppose depending on the null hypothesis, suppose if the alternate hypothesis is mu is not equal to 28,000. If this is the alternate hypothesis, then the critical region is looks like this here. Now because it is a two tail test, then we will have the region of rejection at the both ends. Now alpha equal to 0.01, then we have to distribute it equal, that is here it is 0.01 by 2, here also it is 0.01 by 2. So now for the given probabilities, we have to see what are the Z values here, where so this and this comes under region of rejection and this comes under region of acceptance. So like this, whenever we see a problem related to testing of hypothesis, so first we need to verify whether the hypothesis is related to mean or not. If it's so, is it a hypothesis related to one mean? If it is one mean, then these are the steps we have to follow, that is null hypothesis, then alternative hypothesis. Depending on the alternative hypothesis, we will have an idea on like whether are we going for left tailed or right tailed or two tailed. Then LOS, then the depending on the size of the sample, we decide the test. Accordingly, we see what is the critical region. Once we have the critical region, then we do the calculations. We calculate the Z value or T value, whatever it is. Then we'll validate this. So where the calculated Z value lies in the theoretical value. Depending on this, we'll take the decision, that is either to accept the claim or to reject the claim. So, like this we have to do the problems or discussions related to testing of hypothesis. Now, we will go through this example. Now, here a random sample of 10 is taken, where the IQs are noted as shown here, like 70, 120, etc., etc. And based on this, the assumption is the mean IQ is 100. That means here we are going to validate the hypothesis where the mean IQ of boys is 100. Okay. So, that means here the hypothesis is on mean, that too particularly with one mean. So, therefore, the null hypothesis is mu equal to 100. Now, if it fails, suppose in the process, if we conclude saying that this is wrong, that means the IQ, average IQ can be less than 100 or it can be greater than 100. Therefore, so the alternative hypothesis is not equal to 100. Right? So, based on this alternative hypothesis as discussed, so we need, it can be less than or it can be greater than. That means we have to go for two-tailed test or two-sided test. That we have to keep in mind. So, next LYS is 5%. Now, next thing what we have to do is, what is the tool or statistic we have to use, for which we have to see what is, whether the sample is small or large. If we see here, the size of the sample is 10, which is considered to be small here. And for the information sake, what is the criteria to say the sample is large or small? That is n equal to 30. If n is greater than or equal to 30, then it is considered as a large sample. If n less than 30, then it considered as the size of the sample is small. So, here coming to this, here n equal to 10, that means the sample is a small sample. In case of small sample, the statistic what we have to go for is this t distribution or t statistic, where t equal to x bar minus mu by s by root n for n minus 1 degrees of freedom. Right. So, this is another term which we use when we mention t distribution. Okay. Now, this t distribution is almost similar to normal distribution, where the peakness decreases. Now, so next what we have to do is, now we are going to use t distribution, and for the given LYS, because it is two-tailed test, then we have to distribute it by half here, 0.5 by 2, that is 0.025 here, 0.025 here. Right. Now, this is these two are regions of rejection here as well as here. These both are regions of rejection, and this is the critical region or the region of acceptance. Okay. Now, we know the statistic what we are going to use is t equal to x bar minus mu by s by root n. Then accordingly we have to see what are the values here. Now, in this given problem, they give the entries in the sample. So, based on that we have to find the mean of the sample as well as variance of the sample, right, from which we had S. Then next what we have to do is plug in all these values in the statistics t equal to x bar minus mu by s by root n. Then what we are getting is minus 0.62. Now, t value is minus 0.62. Now, we have to see the critical region. For the LYS 5% and the sample size is very small, therefore, we are going to use t distribution. Then we will have two tails, where the probability here is 0.25, here also 0.25. Next what we have to do is, we have to go and see the t distribution table, where in t distribution tables, for n minus 1 degrees of freedom and given alpha equal to 0.05 by 2 here, n minus 1 is called as degrees of freedom. In case it is 10 minus 1, that is 9 degrees of freedom. So, from normal distribution tables we will get 2.26 as well as minus 2.26. So, where the region of acceptance lies between minus 2.26 and plus 2.26, and the rest of the region comes under region of rejection. So, next what we do is, the calculated value what we had is minus 0.62. Then we have to see where we find this minus 0.62, we will find here. That means this value lies in the region of acceptance. Therefore, the decision what we have taken is H naught is accepted. That means the claim is accepted in this case. So, like this we solve problems related to testing of hypothesis where one mean is considered. So, I repeat here, wherever one mean is considered, then we have to see whether we are doing it with respect to large sample or small sample. In case of large sample, as discussed, we have to go for Z distribution, that is x bar minus mu by sigma by root n. In case of small sample, we have to go for T distribution, that is x bar minus mu by s by root n. So, one important point we have to remember is, whenever we are dealing with large sample, we know that we have to use Z equal to x bar minus mu by sigma by root n. Suppose if sigma value is not available, then we can adjust or we can use the value of s in place of sigma. That is one point we can remember when we are dealing with a problem on large sample. Now, this is how we have to solve problems related to one mean test, whether Z distribution or T distribution, etc., etc., like this. Thank you.